In today's video, I'm going to walk you through a roadmap I wish I had when learning to build and deploy AI-powered apps. This video is perfect for you if you've ever been overwhelmed by all the new tools and libraries, or if you've vibe coded your way into a half-working app using Claude Code or Replit, but then gave up midway. If you felt like you're missing the fundamentals and you eventually want to dig deeper and really understand what's going on, this roadmap is for you. So I've built this 12-week plan for those of you who are serious about learning how to actually build with AI from idea to deployment. It's split into 5 clear stages. In the first stage, we'll be learning core engineering and Python foundations, and then we'll move on to LLM fundamentals that you actually use for AI apps. And next, we'll start learning how to build your AI app from simple version to a more advanced version. And next, we'll learn about evaluating and iterating, and finally, deployment. To make this whole roadmap relatable and easier to understand, we anchor everything around a running example, a simple app called Inbox Copilot. This app will help categorize emails into different categories, summarize the emails, and then draft some reply options. It's a realistic example that covers a bunch of common patterns with AI apps like classification, summarization, and text generation. And you'll be able to adapt the same ideas to your own use case later. Alright, let's dive in. You may be familiar with the traditional software development lifecycle, which usually looks like this. We have planning and requirement analysis, design, development, testing, deployment, and then ongoing maintenance. For AI apps, the lifecycle is similar but slightly different. With AI, especially LLMs, you don't always know how the model will behave until you try it. So the loop is usually tighter so that you can quickly experiment and get feedback. So we start with specifications. Start with writing a few sentences about what the app should do and how you know it works. And this will keep you focused at the start. Then we'll create the scaffold. So setting up the bare minimum, for example, your project repository, environment, API keys, and maybe one simple endpoint. We'll talk about all this in a bit. Then we move on to building, so adding the smallest feature that actually delivers some value. So we're not developing the whole app yet because this is going to be a more iterative process. Once that's done, we will start writing a couple of simple tests and creating a small set of example inputs where you know what the correct output should be. So this will be your reference data set that you can use to evaluate your app later. Then in the next step, we evaluate the application where we measure things like accuracy, latency, cost, and safety, because those matter a lot with AI apps. For more complex apps, you might also want to add some logging for prompts, outputs, and user feedback so that you can see what's happening during testing. After that, we just iterate. So use the data from your tests and logs to refine parts of your app, such as refining the prompts, making improvements in your pipeline, or trying out different models. And finally, we'll ship or deploy the app. Initially, we'll release a small update. This way you can get it into people's hand and loop back to the beginning. With the roadmap I'm going to show you, you're going to see very clearly where all the things you are going to learn will fit into each step in this whole life cycle. Alright, let's start with the first stage, core foundations. Before we even think about AI models or prompt engineering, we need to understand something fundamental. Building an AI app is perhaps 10% of using LLM and 90% of engineering. The AI model itself is just one piece of the puzzle. Everything around it is what actually makes the app work. Most AI apps don't fail because the model is bad. They fail because the rest of the app, including data handling, response formatting, logging, and validating, isn't solid enough. So let's start with engineering basics. Here's what we want to learn. First, we want to learn how to plan a project. We will outline what this app needs to do. For example, for our Inbox Copilot app, This might be first categorize emails, write a short summary, and draft response. And then we also want to learn how to design your app's architecture. This is how all the pieces of your app will interact. And at a high level, most AI applications have a few different layers. Firstly, we have the front end where users interact with your app, for example, through a web or mobile UI. And we have the back end where core logic lives, for example, handling requests, integrating different APIs, processing data, calling the LLM. And then we have the LLM layer, either via the model API from OpenAI, Claude, or Mistral, or local model hosting. Next, we have database or storage layer, where you store user input, logs, structured data, or embeddings. And finally, we have external APIs or tools. They are other services your app may interact with, such as Gmail, Calendar, or vector databases like Chroma or Pinecone. In software engineering, you also want to learn how to write basic unit tests to check if your code still works as you add new features. Another important thing is how to use Git version control. This is like saving version history of your code. This helps you undo mistakes, track progress, and also share your code more cleanly with others. If you're a complete nerd, you might also want to dive into some software development philosophies and best practices, such as how to think modularly, writing your code in small reusable components that each only do one thing. And this follows the principle of separation of concerns and makes your app easier to maintain, debug, and extend. And also some other important philosophies to keep in mind. That is, keep it simple, stupid. That means avoiding over-engineering. Don't build extra features until they're actually needed. And also write code that validates inputs early and give clear feedback. And finally, we want to write code for humans. So name things clearly and document them carefully. Now, moving on, week 3 and 4 are about Python. I've talked about how to learn Python fast in another video a while ago over here if you want to check it out. Python is still the #1 language for machine learning and AI projects. Some coding knowledge will help down the line when you move into more advanced applications that involve more complex backend logic. Of course, in a few weeks, you're not going to become a Python expert, but in the long run, you need enough Python to understand and control what's going on in your app, especially when using AI coding assistants down the line. So if you've written code before in any language, and even if you are a bit rusty, I'd encourage you to learn or brush up on your Python skills. So here's the 80-20 checklist, the 20% of Python that lets you do 80% of AI app development. You need some basic stuff. So variables and data types, control flow, how they works with if-else statements, for loops and while loops, understanding what functions are and writing functions, using data classes to structure your data, which is super useful when working with models or APIs. And moving on, regarding intermediate stuff, you want to know how to set up and manage virtual environments so your libraries don't conflict. Install packages in the environment, read and write from files, for example, JSON, CSV, or PDF files. Some other useful things to know are decorators, handling errors properly using try except, use logging to debug issues, and write and run tests with PyTest, and finally validate an input using Pydantic. By the end of this stage, you should be able to write a simple backend function. For example, a rule-based email categorizer. So this simple function categorizes an email into different categories using specific keywords. And this is, of course, super basic, but that's the point. It helps you understand the shape of the problem. And later, when we replace this logic with LLMs, we know exactly what we are replacing. If you'd like to go deeper into everything we just talked about, from Python fundamentals to AI foundations, all the way through step-by-step project walkthroughs from idea to deployment, then you should check out my Python for AI project course. It's built for complete beginners who want to build a solid foundation and then apply it right away by building real AI apps, starting simple and moving up to more advanced projects. So if you're interested, check out the link in the description below. Someone in the course recently asked me, At which point should you switch from writing code yourself to using coding assistants like GitHub Copilot, Cursor, or Claude Code? My take on that is that once you understand the basic, you can start with the code completion mode. This can help you save a lot of time writing simple and repetitive code. But when it comes to agent mode, where the AI can create files, modify files, or run commands, it is powerful but only safe once you know what you're doing. And if you do want to use agent mode, make sure that you give it the task that is small enough so that you don't get overwhelmed with all the changes that the agent suggests. Now, moving on to week 5, data literacy and data handling. AI apps rely heavily on data. Whether it's input from users, external databases, or knowledge-based documents, or API responses, you need to clean, format, and validate data before feeding it into a model. This is very important because LLMs are very sensitive to noise. Similar to the idea of garbage in, garbage out in machine learning, clean inputs also means better and more reliable outputs in AI apps. That's why data literacy is key. You should be comfortable with identifying different data structure, cleaning messy data such as filling, missing values, fixing data types, normalizing data formats, and so on. You also want to learn how to parse data from different types of files, for example, JSON, CSV, or PDFs, and also transforming and reshaping data into what your model expects. For our Inbox Copilot app, we might receive emails data through the Gmail API, and they might be in the JSON format like this. So we need to extract the subject, the body, and the sender of the email from this JSON response. So here is how the parsing of the JSON email data might look like. Okay, moving on to week 6. Now that you've got a simple working email categorizer and clean inputs, you need to expose it as a service so other parts of your app or other people can actually use it. The simple Python function we just built is great, and it's fine for personal scripts. But once you want to deploy your app, for example, on AWS or Google Cloud Platform or Docker, then you often need to wrap your Python functions as web endpoints, so it can be accessed via a web request. Fast API is a great option because it's using asynchronous workflows, so it means that it can handle many concurrent requests efficiently, which is useful for production apps. And you can also easily plug your backend logic into a front-end later. And also with fast API endpoints, you're preparing for development later down the line. This fast API example simply wraps our categorized email function we had before into a web service. You send it an email object in JSON. The endpoint will first validate if this data has the right fields like subject, body, and sender, and then it will take the email subject, runs it through the categorizer function, and returns the category like billing or question or spam. Now moving on to stage 2, LLM fundamentals. Now that you have a solid engineering foundation and Python foundation, it's time to dive into the fun part, that is large language models. LLMs are what actually power most AI apps nowadays, unless you're using other types of AI models, but I'll just focus on LLMs for now. For week 7, we want to understand LLMs at a high level. You don't need to know every detail, but you do need a mental model of how they work. I'd recommend you at least understand the following concepts. So firstly, tokenization. Secondly, embeddings, attention mechanisms, transformers, and context windows. You just need some very high-level understanding of what these concepts mean and how they apply to your project. A lot of people also asked me if you actually need math to understand LLMs and build AI apps. I think you do need some math to really understand LLMs in detail. Say you want to become an AI researcher. But for building apps, just some light understanding of probability, evaluation metrics like precision, recall, and accuracy, and the idea of optimization is already very helpful, especially when you're interpreting results. Next, we want to know different ways to interact with LLMs. There are 3 main ways to do this. So firstly, through web API, like everyone is doing. If you go on ChatGPT or Claude website, this way is great for testing, but not useful if you want to build build your own product. The second way is API access. This is what most developers use. You send a prompt via an API request and get back a response. You don't need to host the model yourself. And the third way is local models. You can run open source models locally with tools like Ollama or LLM Studio. These models will then run on your own machine, and this way you get full privacy and control, but you need decent hardware and some setup time. Now, moving on to week 8, we have prompt engineering and context engineering. Even the most powerful AI model might struggle without the right context. A lot has been said about good prompt engineering techniques, and you can check out my previous video over here to learn more. However, as your AI app grows, you want to think about context engineering, or the bigger picture version of prompt engineering. The context here is the entire scaffolding around an AI system. What tools it has access to, how information is structured, what memory it keeps track of, and how it adapts over time. Context engineering asks questions like, should the model see previous messages? And if yes, how much? Should it retrieve documents, or should it use tools or memory? This becomes critical when your app becomes more complex. For example, in the Inbox Copilot app, we might design it so the model always sees the company's refund policy before answering any refund-related emails. Another important aspect of building AI apps is guardrails. AI is powerful, but it's not perfect. As soon as you accept user input, you need safety and reliability. OpenAI has this useful document on how to design and implement guardrails for your LLM applications. We have input guardrails and output guardrails. Input guardrails is to filter bad input before it gets to your LLM. And output guardrails, they are guardrails that validate what your LLM has produced before it gets to the consumer. So ideally, we want to implement both input and output guardrails. Of course, this is not strictly necessary if you're just building a prototype or demo, but as soon as you want to release your app to real users, then it's important to have these guardrails in place. Okay, moving on to stage 3, building. In this stage, it all comes together. You've got your engineering foundations, coding foundations, and LLM basics. Now it's time to actually build something. The goal here is to start with building something really minimum and then gradually layering more complexity as you go on. Let's come back again to our Inbox Copilot app example. In week 9, we might start with building something really simple, like a prompt-based version of our Inbox Copilot app. And all what this app does is to take an email input and then send it to the LLM model API, for example, from OpenAI, return the email category, the summary, and the replies. So this is the simplest useful AI app you can build, and I promise it already feels magical. In the following week, we might want to dive into retrieval augmented generation, or RAG in short. We add a RAG pipeline to our app so that it can use external data that we provide. In the Inbox Copilot app, this might be adding the RAG pipeline and the external document, which is the company policies, to allow the app to cite the company policies directly in the draft reply. You can use a library like LangChain or Llama Index to build a basic RAG pipeline for your app. And now your app can actually cite company policies or whatever external documents that you want to use. In the following week, week 11, you might want to start diving into agents. So what you can do is to add some external tools to your Inbox Copilot. This means your Inbox Copilot can not only generate text or categorize email, but can also actually do stuff. For example, you can integrate a calendar API that allows your Copilot to check your availability and schedule meetings for you. You can also add another tool hooking your agent to Gmail API so that your Copilot can actually send an email confirmation on your behalf. If you're completely new to AI agents, I also made a crash course here on building your first AI agent using OpenAI Agents SDK here on my channel, so feel free to check it out. And as your app grows, you might break it into modular agents with different responsibilities, and this is the core idea behind multi-agent systems. So you might want to have one agent for email classification, one for summarization, and one for communication, like drafting emails. And these agents can talk to each other or work in parallel. And you can orchestrate them using some agentic frameworks such as LangChain, Crew AI, or AutoGen. Now, when you start building more serious AI apps with user login feature and that the app has access to memory or external knowledge base, then we'll need to also incorporate databases as well. This is particularly essential for RAG apps or AI agents. So there are different kinds of databases that you can choose from. A popular example is Superbase, which offers traditional relational database, but it also has built-in vector search. And this hybrid option is great for perhaps 90% of AI apps, ranging from chatbots or RAG tool to AI assistant. Other options like Pinecone, Quadrant, and Chroma are specialized vector databases for storing large amount of embeddings and performing semantic search. So you're limited to only pure vector databases. So this is mostly only helpful if you're working with a lot of embeddings, a lot of text documents, and need maximum vector search performance. Okay, moving on to stage 4, evaluation. When building AI apps or prototypes, most people stop at it kind of works kind of stage. But if you want your app to be reliable, trustworthy, and ready for users, you need to evaluate it. And that means that we don't just guess that it's working, but we will actually measure its performance. So this helps building a feedback loop so that we can improve your app further on. Essentially, the evaluation process involves a few different things. First, we have logging everything. So we log the prompts, the outputs, the latency, the costs, and the user feedback. The second thing is to create a reference set or a golden set. These data sets contain the reference input and the expected output. So they are the test cases that we'll be using for our evaluation. Next to that, we also want to define our evaluation metrics. There are different aspects that we might want to evaluate your app on. So this might differ from application to application. For example, for our Inbox Copilot app, we can evaluate the AI-generated replies on the correctness and the tone. Next, we'll actually run the evaluation and compare the generated outputs with the reference outputs and calculate the results on different metrics. And once we have the evaluation results on different metrics, we will start experimenting by tweaking the prompts or adjusting data processing pipeline or comparing different models and different model settings. And the goal is to improve the results on the metrics that we care about. Nowadays, there are many tools and platforms that help you automate evaluation. They also often have a nice UI that you can interact with easily, so you don't even need to code the evaluation itself. My favorite tool is Langsmith from the LangChain team, which provides detailed tracing and evaluation pipelines. Other tools like TrueLens are also great for monitoring and experimentation. Okay, moving on to stage 5, deployment. You've built your AI app, tested it, and now it actually works. Congrats! So the last step is now to deploy it so that other people or even just your friends can actually use it. So the first step, which is optional, is to add a front end. If you haven't already, then this is a nice moment to add a simple user interface. Without this interface, your app will just live as a bunch of Python code, and someone will need to run the app in a terminal, which is not user-friendly at all. So here are some easy to advanced way to add a UI. So the easiest way, if you build your app with Python, is to use a Python libraries like Streamlit. With Streamlit, you can create a simple web interface in just a few lines of code and even deploy the app with Streamlit Community Cloud. This is great for demos and prototypes, but it's less suitable for production apps. The intermediate level way of doing this is to use frameworks like Dash or Django. These tools are still Python-based and they give you a bit more control. And if you choose the advanced option, you can go full custom with React and Next.js if you want to build something really professional and production ready. Honestly, I found that AI tools like ChatGPT or Claude and AI coding agents are really good at creating front ends. There are also tons of templates and even low-code tools like Retool or AppSmith where you can just drag and drop UI elements and edit things visually. So don't stress too much about this. This part is actually very, very doable and fun to do with AI. In the second step, we need to pick a hosting option. Now, for hosting personal apps, I would recommend something really simple and ideally free. For example, using Render or Railway. These are really beginner-friendly hosting platforms. You just need to connect your GitHub repo, and then these platforms will automatically deploy your app for you with just a few clicks. They also offer generous free tiers, so this is perfect for your first app. However, if you want full control and you're preparing for production use, you can containerize your app with Docker and then deploy it on a cloud platform like AWS or Azure or Google Cloud Platform. If you're working for a company and your company is using a specific cloud provider, then you might just need to go with what you have access to. This advanced option gives you maximum flexibility, but it comes with a little bit of a learning curve. Now, in the third step, we want to go from demo to production. Here's the important part. If your app is just a demo or a prototype, say if you're just showing it to a friend or running it on your laptop, then you don't really need to worry about additional production basics. You can skip them and still be fine. But if your app is something you expect other people to use, even just a small handful of users, then these will become essential. Without them, you'll eventually run into headaches, like burning through API credits because someone just spammed your endpoint, or not realizing your app went down until some user tells you. So here's some of the things you want to add to your app once you move beyond the demo stage. So firstly, we have health checks, so confirming your app's backend service is still responsive. Next, we also want to add API key management and other confidentials. This is to protect your app and your API and also other database confidential details. So not just anyone can spam it or steal it. We might also want to add logging and error tracking that captures user prompts, responses, and crashes, so you can debug it later. You can also implement rate limiting, so that would prevent one user from overloading your app. Some hosting providers like Render or Railway already give you some of this for free with monitoring dashboards and error logs, but the rest, like API key management or logging every LLM call, you actually have to set up yourself. Alright, if you made it all this way here, thank you. That already proves that you are really serious about building AI apps. This 12-week roadmap is designed to guide you on the learning path as an AI-powered user. No matter if you're going to do any coding for your project or use AI agents entirely, I believe this knowledge will help you feel much more confident. If you want to take the next step, I've got a couple of things for you. I run a free newsletter where I share my latest insights and experiments in data science and AI. When you sign up through the link in the description below, you'll also get access to the web app I built with the full roadmap from this video, so you can explore it in any time. And for those of you who want the full journey, check out my complete course, Python for AI Projects. It includes all the theoretical fundamentals you need, the examples, code, and detailed walkthroughs from the first line of Python to deploying your own AI app. This is the roadmap I wish I had when I was starting out, and now it's yours. Let me know if I missed anything in this roadmap, and if you go on to build something cool, share it in the comment down below. Thank you for watching. Bye-bye.